Hey, 7th graders. This is the PowerPoint on science processing, graphing, and Système International, or the metric system. No idea why there's a big black box on this first slide, but it really doesn't matter. I need you to go to slide 17, and we'll pick up from there. Hey, 7th graders. So we need to go over the metric system, and I started it with some of you, and some of you we haven't begun this slide yet. So. But either way, I want you to watch the entire presentation. So we need to look at the metric system, and I know all of you have seen this before. You've been introduced to it in elementary school, and I taught many of you, and I introduced it to you last year in 6th grade science. So I know you've heard of it before. So the great thing about the metric system is it is based on units of 10. It's predictable, and it has patterns. Our customary measurement is not predictable at all. There's 3 feet in a yard, 12 inches in a foot, 5,280 feet in a mile. There's no patterns at all, but the metric system is all based on units of 10. Another reason why we use it is because it is used internationally by scientists to communicate data. So regardless of what country you're in, the way that people are going to use data in numbers is going to be in the metric system. Another reason is that it's very precise. If you look at a centimeter ruler, you can make much more precise measurements with that side of the ruler as opposed to the inches or the customary side. Now in 7th grade, we're really only going to be concentrating on these top 4 units. We are not going to spend any time on these 3, so don't worry about those. But we are going to talk about length, and the base unit is meters. Now, we also are going to talk about mass, but the base unit is grams, not kilograms, and I'm not sure why that's on there. Time is seconds. Temperature, Kelvin. Kelvin, we're also going to be using Celsius, and we'll talk about that. And we're going to be doing volume. And the base unit for volume is liter. And I'm going to make my L like that so you can tell it's an L and not a 1. So we're going to see most is length. And the base unit, again, is meter. We're going to do volume. Base unit is liter. And mass, not weight, mass. And the base unit is gram. Meter, liter, gram. Okay, there are some different units that we use. And those are called derived units. And that's when we combine base units to get different units of measure. One of those units of measure that I'm sure you're familiar with is speed, and usually that is always distance divided by time, and you know that because even though you don't drive, you know that it's miles per hour here in the U.S. Everywhere else it's kilometers per hour. But this line means divided by. That's what this line means right here. So we know that it's distance divided by time. Most of you also know the formula for density, which is mass divided by volume. And again, you are taking 2 base units together to make another measurement, and that is called a derived unit. Okay, it's just a fancy word for these things: speed, density, force, area, and volume. So there are different prefixes in the metric system that help you identify what the unit of measure is. And a prefix, the word pre, means before. So the prefix comes before the word, and that determines the measurement. So in this way, we can express very large numbers and very small numbers, and they are all multiples of 10. In 7th grade science, these are the prefixes that we are going to work with. We're doing milli, centi, deci, and here's our base unit, meter, liter, gram, and then deca, hecto, kilo. Now on the next slide, I'm going to be showing you how to use these, and it's all going to make sense. Okay, so what I need you to do now is I need you to get an index card. It cannot just be a half piece of paper or a piece of paper that is the size of an index card. I guess you could use a piece of paper that you cut down to that size. But Or you could get a piece of paper and draw this now and then transfer it onto an index card. But for the test on Tuesday, I'm only going to allow you to use an index card, nothing else. So on your index card, you need to draw a stair step that has 7 steps on it. So 1, 2, 3, 4, 5, 6, 7. Okay? So you should have all these drawn exactly 7. And if you need to pause this video, you can. So on this middle step, this is what we call the base, and that's meter, liter, gram. And you're going to write that right underneath. Base, meter, liter, gram. Now as our numbers get smaller, we go down the stairs, which makes sense. As our numbers go smaller, we go down the stairs. As our numbers get bigger, we go up the stairs. So you can draw in these arrows. And then on each step, you're going to write deci, centi, milli, and then above base, you're going to write deca, hecto, kilo. Okay? So this is what you should have on your index card. Also, you can do this. This is 0.1, 0.01, 0.001, and then this is 10, 100, 1,000. Okay, and all this is going to make sense in a minute. So take a second, pause this video, whatever you need to do, and draw this on an index card. This is the only thing you can have on the index card. And on the next slide, I'm going to show you how to use the card. Okay, so I'm going to draw that stair step again so that I can have something to use here. So here's another stair step. Should look just like the one you have on your card. Again, this is base, meter, liter, gram, and then this is deci, centi, milli, deca, hecto, kilo. Okay, so this is how we use it. Remember, this is smaller and this is bigger. So let's say I gave you a problem that said 100 centimeters equals how many meters? Okay, well, centimeter. So you know it starts here on centi, okay? And we're going to meter here, which is at base. So I'm going to move 1, 2 to get to base. And if you'll notice, I'm going up, but I'm also moving to the left. Okay, this is the right, this is the left. So as I'm going up, I'm moving to the left. So I take this 100 that I had in this problem, and the decimal was here, because you know if there's no decimal, it's at the end of the number. And I have to go to the left 2. 1, 2. So 100 centimeters equals 1 meter. See? 1.00. So that's how you would figure that out. So let me see. Hopefully I can erase this. All right, good. And let's do another one. And we'll do some practice on this on Monday. But you should use the study guide that I gave you to practice this, because we're not going to have a lot of time to do this on Monday when we review. Okay, so I'm going to write these back in. I shouldn't make a slide with this, I guess, but okay, and then this is deci, centi. Okay, so let's take another problem. So I'll say 14 kilograms equals how many milligrams? Okay, so I'm going from kilo, okay, kilogram, kilo, all the way down to milligram, milligram. So I'm going to go to the right. See, as I go down, I'm going to the right. I go 1, 2, 3, 4, 5, 6. So I have to take this number and move my decimal point 6 spaces to the right, because I was going down the stairs. So we know the decimal's there because if it's not there, you know it's at the end of the number. And how many did I say? 6, right? So I have to go 1, 2, 3, 4, 5, 6. All right, well that's going to be a big number because I have to fill these in with zeros. So I have, hang on. Sorry, I almost forgot one. So if I do this correctly, it should be 14 million milligrams. It's a big number. But you get the idea. I had to move it, the number of spaces, I had to move my steps. So let's try another one that maybe isn't such a big number. Let me erase this. Okay. And erase that. Okay, so let me draw my steps back in again, a little bit better. And deca, base, meter, liter, gram, deci, centi, milli. Okay. So let's try one more. Let's see. How about 1 milliliter equals how many liters? Okay, and here's our base liter, and here's milliliter. So I need to go 1, 2, 3 to get up to base. So I need to move my decimal point 3 to the left because I'm going up the stairs. My decimal's here, so I go 1, 2, 3. So 1 milliliter is 0.001 liters. Okay? Now, the best way to get the hang of this is to practice. That is the absolute best way. That's true of everything, especially in math. The best way to do it is practice. So use that second page on that test review to practice. And if you make mistakes, that's fine because we're going to go over it in school on Monday and we'll talk through it. Okay, this slide just shows you how incredibly big these numbers are, which is why we use scientific notation. This is not 10^24, it's actually 10 to the 24th, but the exponents didn't go above the line. So there is actually a number called a yotta, and you would actually say like a yotta gram is 10 to the 24th grams, but that's just crazy. So, and you've heard probably tera, giga, mega when we talk about memory in computers, but you don't need to worry about that either. We're just dealing with these three, and then base, which is no prefix, meter, liter, gram, and then deci, centi, milli. This is all we're dealing with are these 7 right in the middle. But this was just a slide to show you the amount of numbers that you could be dealing with if we didn't use scientific notation, but fortunately we do. Okay, common types of measurements. You're all familiar with length, mass, volume, and weight. So you know length is this straight line distance between 2 points. Measure is the amount of matter in an object. Remember, mass is the measure of an amount of matter in an object. Mass never changes. So no matter where you are in the universe, your mass will be the same. But weight is completely dependent on gravity. Now, it is the force that pulls you to the center of the earth, but the force that is required to pull your mass to the center of the earth. But just remember that weight is gravity dependent and mass never changes. Okay, your volume is the amount of space that an object takes up or the capacity of a container. So if you are drinking a 16-ounce bottle of Diet Coke, then the volume of that container is 16 ounces because that's how much it will take up. Okay, temperature. Remember, we were going to be talking about Celsius for the most part, Kelvin is just for those very extreme numbers. So very hot and very cold. But I don't want you to worry about Kelvin because we are going to be using Celsius. You just need to understand that when we use a thermometer, you're always going to look on the Celsius side, okay? But you do not need to know these conversions. If there are spaces in your closed notes for them, please write them in, but you don't have to worry about memorizing them. Okay, I don't want you to worry about this slide or the next one, so meet me on slide 28. The importance of this slide is something that I need you to recognize and just kind of put in the back of your head because we are going to be coming back to it. When we do conversions within, usually you can't do a conversion within a unit of measurement. So you can't say that a liter equals a certain number of grams. You're comparing two very different things. But with volume, there is 2 units of measure that are the same. And we did this in 6th grade, so some of you may remember. Hopefully all of you will remember. But 1 centimeter cubed is equal to 1 milliliter. So if I said to you, 8 centimeters cubed equals how many milliliters? You would say 8, because they're similar. Because remember, milliliters or liters is volume, but so is centimeters cubed, because remember, volume is length times width times height. So if you have length of a container is 2, and the width is 2, and the height is 2, 2 times 2 is 4, times 2 is 8. So you'd have 8 centimeters cubed because you had 3 units of measure, 1, 2, 3. You could also say that the volume of that container is 8 milliliters. So just remember, 1 centimeter cubed equals 1 milliliter. You can move in between those units of measure. Okay, the good news is we've already done scientific notation. So I want you to actually skip to slide 37. Okay, these are just some rules of the metric system. All measurements must have a unit of measure attached to the end. Zeros mean something. So if you had 5.06, you have to make sure you put that 0 in. You can't just ignore it, and you have to have a unit of measure at the end. No naked decimals. So if it's 0.506, you have to put a 0 in front of it because that tells you that it is a number less than 1. It helps with the accuracy of the measurement. Now, you must have a unit of measure too. And if you'll remember, if you had me in 6th grade, if you don't put a unit of measure, I will mark it wrong. You cannot just answer, if the answer is 5.06 centimeters, you can't just say 5.06 because that's going to be wrong, and I will mark it wrong if you don't put the unit of measure afterwards. Also remember that sometimes if I tell you to measure out to the nearest 1,000th place, you have to include those zeros. Usually I will tell you that to the 10th place is fine, but if I say it has to go to the 1,000th place, you have to include those zeros because it is more precise. So that's it. Make sure that you go through your review for this and practice on that 2nd page. And I will be uploading those documents as well, but take your time with it and we'll go over it tomorrow. Actually, we'll go over it on Monday. See you then.